Hey guys, today we're going to be starting on chapter 4 of the book in section 1, which is on probability. You had an assignment on delta math, which introduced you to some terms, and we're going to build on those a little bit today and then do a little dice rolling experiment as well. So the first thing that we want to define is, well, what is probability? Probability is just some numerical measure. It's always between 0 and 1. That describes the likelihood that an event will occur. So, a little notation here. If you were to try to read that, that is read if the probability of event A. We're going to say P of A, but it's just saying what's the probability of an event happening. If the probability of an event happening equals 1, so let me translate that. The probability of event A. So if the probability of, oh, I guess I didn't know to spell right there. There we go. Probability of event A. So if the probability of event A equals 1, then we would say that the event is certain to occur. 100% chance it's going to occur. If the probability of some event A is 0, well, then the event is impossible. Cannot occur. 0 chance of happening. If the probability of some event A is closer to 1, so maybe like 0.7 or, like 3/4 or whatever, then we say it's more likely to occur. If it's closer to 0, say like 1 out of 10 or 12% chance or 0.12, then it is less likely to occur. Here's a little graphic that I think is kind of helpful here. It's kind of like a little number line here. So we go from impossible is at 0 up to certain at 1. Well, there is no 1 there. And then right in the middle at 0.5 would be even chance. And if it's somewhere in the middle, let's say 1 out of 6 chance, like if you're rolling a dice, you got a 1 out of 6 chance of getting a 4. So it's kind of unlikely. If there's a 4 out of 5 chance that something will happen, then we'd say it's likely. And we could fall obviously anywhere in between there. Now we're going to talk about 2 types of probability, and we're going to be doing these 2 in our experiment that I'm going to outline in just a minute. The first one is called theoretical probability. So in theory, what is the probability, right? Well, in theory, so theoretical is what we would expect to happen just based upon the math. So for example, if I said the probability of rolling a 2 on a standard 6-sided die, well, that would be 1 out of 6. Okay. That would be what I would expect to happen. If I were to roll a dice 6 times, I would expect to get a 2 one of those 6 times. And also write this as 0.16. Or you could even round that to 0.17. Either way. Or you could say, 16.6%, whatever. So this would be our theoretical probability. 1 out of every 6 times I roll a dice, I would expect to get a 2. Now, if I were to actually roll a dice, I got a 5. So next is going to be experimental probability. So if I actually roll it, I get a 5. Then I get a 6. Then I get a 4. I get another 5. Oh, there I got a 2. So it turns out I actually, in my experiment, let's go ahead and roll it 6 times, and I got a 4. Turns out in my experiment, I actually ended up with the same 1 out of 6 as well. And how I would calculate that, we'll see here. We have sort of 2 formulas. Get it to move here. There we go. In the theoretical, our probability is cut by the number of favorable outcomes. In other words, there's 1, 2 on a die divided by the total number of outcomes. Well, there's 6 sides on a die. So that's how I got the 1 out of 6. Now in the experimental, that is the actual probability based on the results of an experiment. So in this experiment I rolled the die 6 times, and it turns out I did actually get a 2 one time out of 6. So that would be the frequency. Frequency is how many times something occurs. That ended up being 1. And the total number of observations, or the number of times I rolled it, which was 6. So I ended up being the same for this one. It doesn't always end up being the case. If I rolled it, I bet if I rolled it again 6 more times, let's try another experiment. 3, 6, 1, 1, 4, one more, 4. So this time, this experiment, I got 0 out of 6 because I rolled it 6 times. So my experimental did not match my theoretical. But theoretically, if I were to keep rolling this 6 times, on average, I would end up getting a 2 1 out of 6 times. So we're going to carry this concept into our little experiment that you're going to do with some dice rolling. Keep in mind these two formulas. So for theoretical, we're going to make sort of a big chart that you're going to use. Number of favorable outcomes just means like how many times they occur on the chart divided by the total number of possibilities. And then experimental, how many times did you actually do it out of the total number of dice rolls? So those are our two formulas, very similar. One is, in theory, what we'd expect to happen, and experimental is what actually happened in the experiment, our actual probability based on our results. All right, so we're going to jump over to our activity here real quick. I'm going to outline this for you, and then you're going to be doing this on your own. Everyone should have different results for the second page of this. The first page should all pretty much look the same. The second one is going to be your own experiment. So you can choose if you want to. I'm going to print copies of this out if you want to stop by my room, or you can print it out on your own, or you can just answer these on your own. It doesn't matter. So we are going to do a little rolling dice activity. The first part is just going to be theoretical here. So the first page, if you want to make note, page 1 is all theoretical. All theoretical. All right, so first question, list all of the possible outcomes when you roll the first die, or one die. Well, you've got 6 sides, right? So you could have a 1, 2, 3, 4, 5, and 6. Obviously, you can do that. And with the second one, you could also get a 1, a 2, a 3, a 4, a 5, or 6. So just assuming you're using a normal 6-sided die. Normal 6-sided die. So you can dust off the old Monopoly game or something, find a die. Same with the second one, you need 2 dice, or you could just roll the first one, or the same one twice, either or. All right, so you guys can do this first two pretty easily. Now, number 3, we're going to list all of the possible outcomes if you roll 2 dice at the same time. So what I'm going to do is make a little chart, and I would do this for yourself as well. I'm going to make a little called a matrix. 1, 2, 3, 4, 5, 6. So these are all the possibilities for your first roll. 1 through 6. And then on your second roll, you could also get a 1 through 6 as well. So I'm going to list these down this way. 1, 2, 3, 4, 5, 6. And you could even do this in this little white space here if you end up printing it off. First roll, and then we got our second roll. All right, so our possibilities, well, we could roll a 1 and a 1. So I'm going to put a little coordinate pair. We could roll a 1 and a 2. Could roll a 1 and a 3. Could roll a 1 and a 4. Could roll a 1 and a 5. 1 and a 6. That'd be one set. We could roll a 2 and a 1. A 2 and a 2. A 2 and a 3. A 2 and a 4. 2 and a 5. And you get the idea here. 2 and a 6. And then we go to the next one. We could add a 3 and a 1. A 3 and a 2. 3 and a 3. So you're going to get this chart here. You're going to have 6 rows and 6 columns. So you should end up with a total of 36 outcomes. You are going to want to do that. You then are going to just list them here on number 3. So you're going to write 1 and a 1, 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6, and then go to the next one, and then a 2 and a 1, 2 and a 2. So just go through and do that all the way up through all 36 of them. So we do have a total of 36 outcomes. We're then going to answer some questions based off of this. So the first question, we're going to say if these are certain, likely, unlikely, impossible, or equally likely. So let's just look at the first one. We're going to be asked the sum of these. So when we roll 2 dice, what are the chances of the sum of these 2 dice being greater than 12? All right, well, let's just think about this for a second. If we roll 2 dice, we could get, the highest numbers we could get would be a 6 and a 6, right? So the highest sum that you could get would be 12, right? So what are the chances of the sum being greater than 12? Well, that's impossible. You couldn't have a 7 and a 6, so this is going to be impossible. So rolling 2 2s or 2 4s. Let's think about how many ways that could happen. For 2 2s, that's only going to be 1 here. And then eventually we'll get down here and we'll get 4 4s. Or sorry, 2 4s. So that's really only 2 chances, right, out of this whole thing. So that's going to be pretty unlikely, right? Unlikely that we would get double 2s or double 4s. So go ahead and fill in the rest of that from there. And then this little chart here, we're also going to fill in probability of rolling these certain ones. So you're going to want to look at this little chart, a 1 and a 1. You're only going to see that in one place on this whole chart. So the probability of rolling a 1 and a 1 is just going to be there's one chance out of 36 possibilities, 36 possible combinations. So write 1 out of 36. And it's a good idea to just go ahead and write the fraction and the decimal. So then just write 1 out of 36 equals 0.0 and then 27. Good. So the next one, both even numbers. So what you're going to need to do is look through this chart and find the possibilities where you could get both an even number. I'm not going to do all of them for you, but you can actually rule out the entire first row because all of those have a 1 with them, right? So they're not going to both be even. Now the second row would be good to look at because it starts with a 2. So a 2 and a 2 would be 1, 2 and a 4, and a 2 and a 6. You could rule out the entire third row. You would want to do the fourth row, and then you're going to have obviously a 4 and a 2, 4 and a 4, and a 4 and a 6. So you can figure it out from there. Figure out how many total ones you would have. You can circle them. And then it's always going to be over 36 because we have 36 possibilities. Probability of rolling a 2 and a 3. Make sure you look at a 2 and a 3 and also a 3 and a 2 for that one. So you can figure the rest of that out. All right, so that's the theoretical part. Using this chart that we've made, answer these theoretical questions. All right, the next one is going to be a little experiment, but there also is a theoretical part of that as well. All of these are going to ask you questions about the sum of your dice. So we might want to use this prior table that we made, but we're going to make a little new one that's going to tell us the sum. All right, so this is going to be our sum table. So we're going to start by doing the same thing. 1, 2, 3, 4, 5, 6. And a 1, 2, 3, 4, 5, 6. And with this one, we're going to go through and let's say we get a 1 and a 1. Well, the sum of that is going to be 2. Let's go ahead and do this. Because if I roll a 1 and a 1, I get a 2. If I roll a 1 and a 2, I get a 3. If I roll a 1 and a 3, I get a 4. 1 and a 4, I get a 5. 1 and a 5, I get a 6. 1 and a 6, I get a 7. The next row, a 2 and a 1 would be a 3. 2 and a 2 would be 4. 2 and a 3 would be 5. 2 and a 4 would be 6. 2 and a 5 would be 7, 8. And I'm going to go ahead and do the rest of these. You'll start to see a little pattern here. They just go in order, just so I can show you first couple examples. So you're going to want to write this out on your own as well, so you can reference this, make sure you get the answers right. All right. So the first part is going to be theoretical solving, this part over here. So on a standard 6-sided die, if you roll it twice, or in other words, if you just roll 2 dice, it's the same thing. What is the probability that the sum of the 2 rolls is 24? Sorry, no. What is the probability that the sum of the 2 rolls is 4? All right. So what we're going to do is look at our table find all of the places where we can roll 2 dice and get a 4. Well, it turns out there's only 3 of them, right? There's 3 4s in there. So that's going to be 3 out of 36. You could also actually even just reduce this. This would be 1 out of 12. But then go ahead and also write it as a decimal in all these, because you're going to want to compare it to the experimental, and you won't necessarily have the same denominator. So go ahead and make them all a decimal as well, so you can compare. It's 0.083. So the next one, if you roll standard adult twice, what is the probability the sum is less than 5? So you're going to find all of them where it's going to be less than 5, which would be these over here. So 1, 2, 3, 4, 5, 6. So you would have a 6 out of 36 chance. And so you can get it from there, 1 out of 6, figure out what that is as a decimal. So that's what you're going to be doing on the theoretical. Then you're actually going to do a little experiment. You have 2 options as far as dice. It does say to conduct 25 trials. However, for whatever reason on this chart, they only gave you 24 little places there. So add a little 25th one. So make sure you do 25 trials. And you're going to roll 2 dice. So you're going to write what you got for the first roll, the second roll, and then the sum. And then you're going to be computing your experimental probability. So based on these results, and how many of the trials was the sum of the rolls, 2 rolls 4. So let's say you had 5 times when you got, let's say you have 4 here, 1, 2, 3, 4, 5. So 5 times where the sum was a 4. So you're going to do 5 over. Now it's not going to be 36 because you rolled the dice 25 times. So it's going to be a 5 over 25, or 1/5, which is 0.2. And then you're going to answer whether it's the same as the theoretical or not. Well, this was 0.2. It said it was only supposed to happen 0.08 times, so this would be a no. So you're going to compare your experiment to your theoretical probability in all of these. Now, as far as rolling the dice, you do need to do this on your own. So everyone's going to have a different table here. If you have the same as someone else, then I'll know that you cheated on it. So everyone should have different results. Ideally, I would like you to roll 2 dice if you have them at home. So just grab 2 dice, roll them out. So if I rolled a 6 and a 4, then I'm just going to write 6 4 is 10. And then I roll again. Let's say I get a 1 and a 3. So got a 4. You're just going to go through and do this. Now let's say you can't find any dice at your home. No fear. You can still do this. There is a website. If you just type in like random dice roll into Google, I'll also link this in the assignment. Click on this dice roller. And then just click allow selected is fine. You're just going to ask it to roll 2 virtual dice. So you're just going to hit roll dice. You get a 1 and a 1. You roll, it says roll 2 dice, you get a 1 and a 1. So then on my paper, I'm going to write 1 and a 1, which is 2. And then just do it again. You just click roll again. So this is easier, but it's not as fun. You get a 4 and a 1. So that's a 5. So very easy to do that. You can definitely all do this on your own. It's rolling the dice for you and giving your results. So make sure you answer all these questions, compare your theoretical to your experimental, answer whether they're the same or not. If you're confused about this in any way, don't hesitate to send me an email or stop by my room or whatever and let me know. Make sure you're writing out these 2 charts. So your first chart, I would do this one where you're just writing the pairs. And then on your second chart, I would do it with the sums. So you're going to need both of those in order to solve these theoretical parts well. All right, good luck, guys.